Okay, so you're going to have three different sections of problems. I'm just going to go through the three different sections, do one problem type for each section, and be done. So, again, no new rules or anything. We're still in 5.1. The first type is going to have you multiply and simplify. So they're going to give you a multiplication problem. You multiply it out, and then you simplify whatever you get for an answer. Again, a lot of this is still just trying to get you into the frame of mind that wherever you're dealing with these, you're still treating them just like they were variables. So whenever I multiply this, I still just FOIL it out just like normal. So I take cotangent times cotangent. I take cotangent times negative cosecant. I take cosecant times cotangent. I take cosecant times cosecant. Oops, that should be a minus, sorry. Now, if you looked at it beforehand, you could see that this was difference of squares. I just wanted to go through the multiplication process. So these middle two cancel out because one is plus, one is minus, but they're the same two terms. Okay, and then that you have a Pythagorean that is this. So if I rearrange this, and then I could take everything times the negative 1 and get this. So all this comes from a Pythagorean. This here is one of your Pythagoreans. So by rearranging a Pythagorean, I can get that this is a negative 1. Now, let's see that you don't see that. Yeah, go ahead. The way I would suggest doing it is I would memorize the first Pythagorean, and then wherever you get a quiz or something, write down the first Pythagorean and then get the other two. Now, if you want to memorize them all, that's fine. Now, let's say that in your head you don't see this. That's fine. So, I need to simplify this. Another way you can do this is I would still suggest using a Pythagorean. But take this and say, okay, well, I know that. So here's an alternate way. Okay, I have cotangent squared in here. So I know that cotangent squared and cosecant squared are related by a Pythagorean. So what I can do is I can do this and get cotangent squared by itself in the Pythagorean, like that. And then I can replace cotangent squared with this. So instead of eliminating it all at once, what I did is I just eliminated the cotangent squared with the Pythagorean. So now I have two cosecants, and what's cosecant minus cosecant? The cosecant squared and the cosecant squared would cancel out, correct? So this would cancel with this, so I still just get negative 1. So there's more than one way to get to your answer. So, in my head, I saw that, oh, I can manipulate my Pythagorean and just get all of this to cancel out at once. If you don't see that, we'll just eliminate one thing. Just eliminate your cotangent. It will still work out.
Why was it -1 then?
Which way?
The Pythagorean?
Both of them use Pythagorean. This way,
Yeah.
I took and I moved the cotangent over here, but that's not exactly what I needed because I need to have cotangent minus cosecant. So I multiplied everything by -1.
Okay, I got you.
So I don't want you guys thinking that you have to do it exactly how I'm going through it. There's always more than one way. Okay, with example 2, you're going to be given something that looks like that, and you're just going to be asked to simplify. Anytime you're given something like this, you always want to start by just adding your fractions together. Get like denominators and add them together. So what does this one need for to get common denominators? It needs a sine theta. Right? This one is missing a sine theta, so what I'm going to do is I'm going to take this one times sine theta over sine theta. Okay, and what is this one over here missing? It needs that 1 plus cosine theta, right? Okay, so then let's see. I have sine squared theta over they would do what? This, I could cancel that out, but that's just going to undo what I just did.
Like the top one and the first one, the bottom.
I can't cross cancel, no. Okay, I want to multiply out my numerators because whenever I add, I just add numerators. Denominators, I'm just going to leave that factored. That way if I can cancel something out after I add, I can do that. So multiply out your numerators. Denominators, you can leave that factored. Unless you think multiplying it out will have some effect of simplifying, but most of the time it won't. Okay, so I add them together. I'm going to rearrange this a little bit because I know what's going to happen. Okay, so what is sine squared plus cosine squared? 1. That's your Pythagorean. So remember, you have your Pythagorean. Sine squared theta plus cosine squared theta equals 1. So I can just take this entire piece out right there and replace it with 1. So then the cosine theta, the 1 plus cosine thetas cancel out. Remember, whenever you're dealing with things like this here is considered one thing. You cannot cancel any piece of that out unless you can cancel the entire thing out. Well, I'm lucky enough that I have the entire thing on top, so I can cancel the entire thing out. Okay, so 1 over sine theta, which I'm not done because that's still a fraction, so cosecant theta. So that is a lot simpler than what I started out with. So every time you see two fractions, you're going to want to add them together.
If you cancel thing on the top, how do you
Well, anytime I have two things above each other that are the same, it always equals 1 over 1. It's just the bottom one times sine is just sine. Okay, example 3, last one. You're going to have some problems that just give you a single fraction thing like that and ask you to rewrite it so that it's not a fraction. The way we do this is by using the Pythagorean. We literally want to create the Pythagorean. We do that by multiplying by the same thing, just the conjugate of it, which means same thing, opposite sign. Okay, 1 minus sine squared x. So let's go to our Pythagorean and figure out what that equals. Now, again, there's multiple ways of doing this. Yeah, let's do this a different way. Let's do this the long way. Because I think those of you who get it the short way, you'll be able to do it the short way whether I show you or not. Okay, Pythagorean. What does 1 equal in your Pythagorean? Sine squared plus cosine squared. Right? Pythagorean is sine squared x plus cosine squared x equals 1. So I'm going to take out the 1 and replace it with that. Right? Pythagorean says cosine squared x plus sine squared x equals 1. So I took the 1 and I replaced it with that. Yes. Yeah. That would be the short way, but again, I'm choosing to do the work inside my problem instead of out here to the side for this one. But yes, you could do that. Okay, now I have sine squared and a minus sine squared, so what happens with those two? They cancel. Okay, the whole point of this was to get rid of the fraction. So now that I just have a cosine on the bottom, what is 1 over cosine? Secant. So now my fraction is gone. Remember, that was my only goal. It looks worse, but the point of this actually has to do with calculus, because when we're integrating, sometimes it's easier to integrate whenever we don't have a fraction. All right, so that's it. Those are your 3 types of problems that they have you doing. That is everything that will be on the quiz. Again, the only difference is on the quiz, which we'll cover this again tomorrow if I'm here. But the only difference between this and the quiz is on the quiz, your problem would look like this. That's the way your quiz problem would look like. So you would just do all your work over here and show that this side equals cosecant theta. So that's going to be section 5.2 tomorrow. So it's giving you the answer. Yeah, so what? What? Good.